Well, good afternoon, everyone. Hope everyone's doing well today. We're going to go ahead and kick this off. My name is Greg Schmidt. I'm an application engineer at Precision Roll Grinders. Today, we're going to look at what my role in the company does, but more importantly, what we do to help our customers. My role in the company is to help our customers determine the value that we are providing them in their process. We use a variety of methods, but we focus really on using a Six Sigma style method to define and quantify the improvements that we're bringing to you. Many of you may have already seen the DMAIC or DMAIC process. This is very common in the industry, and we work with our customers to design an experiment to look at a certain aspect in the process and look for improvement. We take measurements, or we can use customer data to look at a before and after change or improvement from before and after when our rolls are installed in their machine. We use Minitab to analyze this data, and then after we've come up with and discuss the results, we look at process improvements, and then going past that, we look at how to control that process. And for certain industries, we can even create a predictive equation for when rolls need to be changed out in the future. Now, at Precision Roll Grinders, we focus on high quality precision grinding and roll servicing. We can reach tolerances in our grinds up to 40 millionths of an inch, which is world-class tolerances. On top of that, we have world-class surface finishes and optical properties, which often is overlooked, as the RA, or your surface finish, is just as important as the roll geometry or the grind. And using these aspects and these quality grinds and surface finishes, again, we want to look at that data and show how that is helping your process. One of the defining differences of Precision Roll Grindness is that we grind our rolls on the journals. We remove the housings and the bearings and take all that error or play or the clearance in your bearings, we take that out of the equation, which when you're looking at the tolerances that we grind to is extremely important. This shows a perfect example. You've got an extreme example there on the left of a roll that was ground with bearings and housing, or excuse me, on bearings. And you can see how much variation in the roundness of the roll there is. Whereas you can see when it's ground on the journals, you have almost a perfectly round roll. This also helps remove barring entirely, which is very important, and we'll discuss here later on why that's important. So this shows a perfect example of why barring can be such a problem, and it's critical to remove it. There on the left-hand side, you can see impression paper, where you can very much visualize what the barring is doing. This is creating machine direction variation, and there in the middle picture, you can see as a result of what that does in the corrugation and reel spool at a paper mill. This can also cause a huge amount of strength variation, and as a result of that, you have additional scrap and other detrimental items. Crowns are critical on rolls as well. This applies to any industry with a crowned roll, not just paper or one industry. This could be plastics, rubber, or anything else. When you're looking at the crown on a roll, in a perfect world, when that roll is under load, you should have a uniform nip all the way across from front to back on the machine. If that nip is not uniform, you're going to have a thick or thin side, and not only are you throwing away a massive amount of scrap as a result of that, but you're having to adjust your machine or your process to compensate for that. So crowns are incredibly, incredibly important. And again, this is an example of a before and after versus target with our grinds. Now, PRG is very well known for its calendar roll performance, but we do all rolls, including press rolls. And it can't be stressed enough that the tolerances we can give you on press rolls has a big impact on your process. This would be for paper and a press roll performance. And as you can see before, you had moisture streaks throughout it. This was an actual study that was done. And after, you can see the moisture average was not only more consistent, but actually bumped up slightly. This can help increase production, you can increase machine speed, and you also don't have to worry about evening out those moisture streaks in the drier section, as that is a huge energy problem. So this are some of the numbers you would expect to see from before and after. You can see there's an improvement in the real moisture, there's an improvement in the real speed, and as a result, the production rate is also increased. And the numbers speak for themselves. You can see you're going to have increased production. That is costs that you're wasting if you're not able to achieve those numbers. And again, you don't want to be drying the sheet in the dryer section as it's incredibly inefficient. Another thing that PRG focuses on is concentricity. This is not something that, or it's something that a lot of times is overlooked, that's not focused on. And concentricity is just as important as any other aspect of the roll geometry. If you have poor concentricity, you're going to see an uneven sheet, you're going to see material losses, and you will see a shorter roll life. And so that's something at PRG we really focus to make sure your grind is concentric. So this was a example of a study that our application engineers have done at PRG. And in this process, we actually manually collected close to 10,000 data points. This would be an example of when the customer doesn't have their own data set, and we designed and made the experiment where we could collect the data ourselves and get these results. As you can see, there is a significant change. If you look at the bottom left of the screen, you can see the before and after graph. You can see that we shifted the entire mean significantly to the left, which happened to be much more within spec for our customer, as well as significantly reducing the standard deviation or the variation within the process. You can see there was almost a 50% improvement from out of spec to in spec, and like I said, the variation was improved as well. Now, this graph was actually made off of another study as well. One of the improvements that you're going to see with our rolls on our service is that they last longer. You can see in this example, a roll that was ground at 2 10,000ths versus 8 10,000ths, how much longer it can last. And again, this was an actual study that was done. If you put a roll in that, in this case, is only 6 10,000ths of an inch different, because it doesn't have those high tolerances, the moment you start running in that machine, it's already wearing at a higher rate than if you had a lower tolerance. And as a result, in this case, you can see it made a massive improvement, taking the life of the calendar roll from 6 months to well over a year. Another case study that we did showed a huge improvement in the short span tensile strength test, improvement of 54%. This allowed for a basis weight reduction of 0.2 pounds. And because of that, you could potentially increase your machine speed, and you could also have a fiber cost reduction. And there at the bottom, again, the numbers speak for themselves, and it can make a huge impact on your process over the course of a year. This shows, again, another example, we saw this picture earlier on with the barring. This was another real case study, and as a result of less barring, and you can see less corrugation in your reel spool, it was reducing the spool losses by 250 pounds per reel. And again, over the course of a year, you were looking over $300,000 of scrap that wasn't wasted. And on top of that, they saw a huge reduction in winder breaks. Another thing we work with our customers to do is to create spreadsheets to come up with estimates of how much savings we could offer them if they used our product or currently using our product. This is an example of it, and all of these spreadsheets are tailored to specific customers and whatever their process is. And we will work with you, sit down with you, and figure out exactly all the different elements that would go into this. There'd be material losses, time wasted, et cetera, and we can put together a specific spreadsheet to you just to estimate your return on investment or how much you might save over the course of whatever time period. So It's important to say that PRG, we are not just grinding, we are a full roll service provider. You can see this is not a complete list, but this is just a few of the things that we offer. We have our bearing inspection, we give you a complete roll inspection report, dynamic balancing, leak testing. We have a variety of non-destructive testing types to help diagnose problems, and we repair journals. We can do new journals, modifications to existing rolls, as well as a variety of tests on suction rolls. So the PRG, we really focus on the mechanical excellence. Again, we are not just grinding, we are a full roll service provider. And so this involves going through the bearings. We have uh, individuals from the OEM bearing companies come in and inspect your bearings to make sure they are within spec before they go back on your roll. If they are not, then we will recommend replacing that bearing. Bearings are extremely important, and if they are not inspected properly or you have a problem with it, that can take down an entire production line or machine in a split second because of bearing failure. So it's very important that all the mechanical aspects of a roll are inspected, verified before they are serviced any further. We replace damaged bearings, bushings. We have the journal repair and placement, which I mentioned before. And as a result of this, we also can get you started up and running production line quicker. We have expedited roll service, and so we can get you up to speed quicker than anyone else. We also service all your heated rolls. Uniform roll surface temperature is critical in lines that use these rolls. When we tear these down, we make sure all the passageways are completely cleaned. We have descaling to clean these out. If you have a passageway that's clogged, you're going to have a roll that when it's heated up, its geometry is out of spec. And so you really want to make sure all those passageways are completely cleaned and that they have a good flow through them. Now, obviously with COVID, we've had a lot of time to adjust to our new virtual partnerships, how we call it. You know, it's much harder to see a lot of customers face to face. We're all getting used to go-to meetings and Skype and this online contact because we can't see each other face to face. And so we're really trying to work with our customers, you know, especially the ones we can't see face to face, to really, you know, keep helping you as much as we can without being there on site and to see what we can do for you. Now, going back to the application engineering, as a result of COVID, we started offering a virtual value-added services. Now, this still entails the same rigor and depth Six Sigma process that we use, but we have to collect the data or the samples virtually. So we will work with customers to collect the samples. They could send us samples, and then we do the measurements on them, or sometimes it's just a data set that a customer already has, and they can just send that over to us, and we can do an entire analysis without actually having to be there in person. And on top of that, with all our account managers, we work with all our customers one-on-one with them, you know, via pics, video, online calls, so where we can try and troubleshoot a problem via just pics or video since we couldn't be there in person. So again, the application engineering, we want to show the economic value that we are providing with our services. And we will work with you to design an experiment, whether it be on your entire process or one aspect of your process. We will implement a plan for the variation improvement, and then data analysis on improved process, or the predictive equation, which was brought up before. And as always, if you have any questions, you know, don't hesitate to reach out with us. You know, we have 4 facilities. We service all the US and internationally. You know, feel free to call us, ask questions at any time. That's what we're here for. And with that, I will go ahead and wrap this up. If you have any questions, you can put them in the questions chat, and I will stay on here for a moment and answer those questions. If you don't feel comfortable posting a question in the chat, that is fine. You can call us at our facility and talk to us individually, and we can answer it there. And as always, thank you for joining, and we will see you next time.